In Lesson 5, we will conclude this course on the LTE Application Framework. To review, the purpose of the LTE Application Framework is to provide a reference implementation of a common wireless standard. The LTE Application Framework provides you with complete access to the source code, a modular and easily modifiable design, and ready-to-run streaming example out of the box. This is intended to be a starting point for the implementation and validation of new algorithms, systems, and testbeds. Out of the box, the LTE Application Framework provides two main prototyping scenarios. The first is where the eNode B is on one FPGA and the UE is on a second FPGA, and you can have bidirectional communication over the air. The second scenario is where the eNode B and the UE are on one FPGA, and we are just doing the downlink. Note that this system can be expanded in many different ways. For example, MIMO could be implemented, or the eNode B could be communicating with two UEs who are also talking to each other in a device-to-device type of scenario. We also talked about prototyping approaches using the LTE Application Framework. The two main approaches were top-down and bottom-up. To review, in top-down, we start with the existing system and edit some modules or add some modules, but generally reuse the same overall system and architecture. Bottom-up, instead, means you build your own system and own submodules, and you use some of the existing modules from the LTE Application Framework as smaller building blocks. We also talked about the available building blocks or modules that are implemented in the LTE Application Framework. To review, the transmitter has channel encoding for the data and control channels, resource mapping and OFDM modulation, while the receiver has synchronization, OFDM demodulation, channel estimation and equalization, channel decoding for the data and control channels, resource demapping, and real-time configuration of the data channel based on the control channel. We also learned about selected specifications from the 3GPP LTE standard on how the downlink, the special, and the uplink subframes are configured in resource blocks. We also discussed the different options available for actually programming the FPGA. These are covered in more detail in the guided helps in Lavi Communications and in the Lavi Communications training course. But essentially, there's the low-level clock-driven logic and the high-level multi-rate diagram and optimized FPGA VI. Based on the data in the chart, this should help you choose the right tool for the job. We also discussed fundamental techniques for FPGA programming, such as 2-wire handshaking versus 4-wire handshaking, and the trade-offs of using one versus the other. And we saw the different ways that we could actually connect the modules that we implement together, whether we use FIFOs, handshaking with 4 wires, or handshaking with 2 wires. We also learned how specific modules have been implemented on the FPGA, such as the PDSCH and PUSCH turbo encoder. So you're probably asking yourself how to make an impact on 5G. And what we've seen is through these proof of concepts of new technologies, this really helps push the industry forward. Using the LTE Application Framework, you should be able to use this as a starting point for prototyping new ideas, either by replacing existing modules, modifying existing modules, or implementing your own modules using CDL, the multi-rate diagram, or some of the other languages. We always recommend taking the time to write a host test bench for your FPGA code so you can simulate and verify that it works properly and functionally before going through lengthy FPGA compiles. And finally, by leveraging the FPGA, you'll be able to demonstrate promised gains with real-time and over-the-air experiments. Thank you very much for taking the time to go through this training course. My name is Rahul, and I am a product manager on the Software-Defined Radio team. If you have further questions, feel free to check out the ni.com website on Lavi Communications and our software-defined radio technology, or email us at lavu.communications@ni.com. Thank you very much, and all the best in your work.